Today we start the next point in reciprocal lattice, that is Brillouin zone. The concept of the Brillouin zone was first developed by the French physicist Léon Brillouin. That concept gives geometrical interpretation of diffraction conditions. To explain the Brillouin zone, we must know about the zone. Such a here zone is an smallest region in a real or reciprocal space lattice. Hence the space lattice, it should be real or reciprocal. In that space, the smallest region represents a zone. Such a smallest region about a lattice point is known as Wigner-Seitz cell. So what is that Wigner-Seitz cell? That we define firstly. We define Wigner-Seitz cell. It is the smallest region. It is the smallest region in space that closer to a given lattice point than any other point. That smallest region is a Wigner-Seitz cell. Now, how the Wigner-Seitz cell is constructed? For that, we have to use two-dimensional lattice. In that two-dimensional lattice, we draw the geometry. That here this geometry shows the lattice points. We choose the center point as a origin, and from that origin we select the closest points. That closest points we join by the dotted line, and we draw a perpendicular bisector to each line through the midpoint. Also we draw the another bisector for another line. Similarly the vertical from that line also we draw here that one, and the innermost region which is bounded by these four bisector is a smallest region. That region is Wigner-Seitz sail. We also draw another six-sided Wigner-Seitz sail that also represent the smallest region by using the another geometry of the lattice point. That geometry, using that here the geometry, we find the Wigner-Seitz sail is we choose the center point as the origin, and from that center point we join the closer lattice point by this dotted line. Then same procedure as like earlier, we draw a perpendicular bisector through the midpoint of each line on the other side. Similarly, that much, and we again draw this much, and it form again that smallest region. That smallest region is again acts as a Wigner-Seitz sail. Hence, we again here this finding here the how to construct the Brillouin zones, different Brillouin zones. In reciprocal lattice. In that once we construct the Brillouin zones in the reciprocal lattice, these are constructed from by using Bragg's plane. Hence, what is the Bragg's plane? That we define firstly. Bragg's plane, it is an perpendicular bisector. It is a perpendicular bisector to the line joining the origin of reciprocal lattice space to any other reciprocal lattice point. By using that Bragg's plane, we construct the various Brillouin zone. Firstly, we construct the first Brillouin zone using the Bragg's plane, and the Bragg's plane, it is an perpendicular bisector to line joining the origin of reciprocal lattice space to any other lattice point. Hence, we construct the Bragg's plane by using the geometry. That here this geometry we just considering reciprocal lattice points in a reciprocal space As like the earlier procedure, we choose the center point as a origin in the reciprocal lattice space, that is the origin, and from the origin center point we choose the closer reciprocal lattice point. We join origin with the reciprocal lattice points. It represents a reciprocal lattice vector, and once we draw a perpendicular bisector to the reciprocal lattice vector through the midpoint, we get a one plane. That plane is a Bragg plane. Similarly, we also construct the another Bragg plane for another reciprocal lattice vector. Similarly, vertical Bragg plane for the reciprocal lattice vector. Therefore, by enclosing the four Bragg's plane, there are here how many planes we can get? 4 Bragg's plane. This Bragg's plane enclose the innermost region. That region is nothing but first Brillouin zone. Hence, how we define the first Brillouin zone? First Brillouin zone, it is an the Wigner-Seitz cell Wigner-Seitz cell about a lattice point. Now we have to just draw it here. Wigner-Seitz cell about a lattice point in reciprocal lattice, or it is also defined as it is the innermost region bounded by 4 Brillouin zone. It is also known as first Brillouin zone. Hence, another Brillouin zone we also construct by using the Bragg's plane. For that, we use the geometry. That geometry is we use 5 by 5 reciprocal lattice space. In that, we select the center point as the origin. That center point we call as a O, and from center point we choose the nearest neighboring lattice points. These are shown by red points. It represents a first set, and that first set gives the first Brillouin zone. Now, how we construct the first Brillouin zone? We draw the perpendicular bisector to that line. Hence, perpendicular bisector, we draw that line. Similarly, for other closer point, also we draw another perpendicular bisector. Similarly, for that one, also we draw a perpendicular bisector. It is an Bragg's plane. this another one, and that region which encloses by the first set of the point which are closer to the center point, it forms the first Brillouin zone, or we say this is the first Brillouin zone. Second Brillouin zone we construct by considering the another set which are closer to the center point. These are shown by this yellow line, yellow points. We also join these points with the origin and draw a perpendicular bisector to that line. That perpendicular bisector, for that line we draw, this is one line. This is first line. Similarly, for second line, we also draw for that one. Second Bragg's plane, which is passing through that point. This is second line. Similarly, the third line, next line. This is third Bragg's plane. Next Bragg's plane. Therefore, another Brillouin zone which encloses by the second set of the points which are closer to the origin, that we call is the second Brillouin zone. This is the second Brillouin zone. First Brillouin zone, that we denote by innermost region bounded by the first Bragg's plane, that we call this is the second Brillouin zone. The first Brillouin zone is blank region inside the Bragg's plane. Then next, third Bragg's plane, we draw it here, third Brillouin zone. For third Brillouin zone, we also draw the various Bragg's plane. This is the third set. That third set is shown here by blue points. Now we join these points with the origin and draw the perpendicular bisector. That perpendicular bisector we draw like here. Similarly, other perpendicular bisector. Similarly, next one, this is next perpendicular bisector, that bisector. Now it forms the third Brillouin zone. The third Brillouin zone that we draw it here. Blue lines. Here also. These are the blue region which formed due to third set of the reciprocal lattice points about the central point, and it gives the third Brillouin zone. In that figure, the first Brillouin zone, second Brillouin zone and third Brillouin zone we completely draw here. Now by using the fourth set of the points, we draw Bragg's plane and they enclose the region in between first, second and third. That Brillouin zone is fourth Brillouin zone. That fourth Brillouin zone we draw using these points, green points. These are the fourth set, and that fourth set form the fourth Brillouin zone. For that we join the center point to that point and we draw a perpendicular bisector to that line. That perpendicular bisector we draw. Similarly, here also we join that point with the origin, and we also draw a perpendicular bisector to that line, along that line, and we get that region. That region is fourth Brillouin zone. This is the fourth Brillouin zone. Here also we use these 2 points and draw the perpendicular bisector for that line. We get this is the fourth region. Similarly, here also we draw. This is the fourth region. Here also fourth region. In that way, we draw the various Brillouin zones in the reciprocal space lattice. The first Brillouin zone is the innermost region enclosed by the 4 Bragg's plane. If we join the center point to first set of the point and draw the perpendicular bisector, that perpendicular bisector is known as the Bragg's plane. That region, innermost region, is the smallest region that we call the Wigner-Seitz cell in the reciprocal lattice, about a point in the reciprocal space, that is the first Brillouin zone. The geometrical construction of the first Brillouin zone and Wigner-Seitz cell in real lattice is identical. Second Brillouin zone, second Brillouin zone, second Brillouin zone. Second Brillouin zone. How we defining here? It is the region of the space which cross first Bragg's plane. That region is second Brillouin zone and it is denoted by green yellow region, that is the second Brillouin zone. First Brillouin zone, second Brillouin zone. Third Brillouin zone is, we define in the same manner. It is the region in the space which cross first and second Bragg's plane. That region we call third Brillouin zone. Hence, the third Brillouin zone we are also defining here. How we define? It is the region of space. It is the region, the space which cross first and second Bragg's plane. Similarly, we write the nth Brillouin zone. It is also the region of the space which cross n-1 Bragg's plane. And these are the simple construction of Bragg's plane by using reciprocal space lattice. These are constructed by using Bragg's plane. That Bragg's plane is a perpendicular bisector to a line joining center of the reciprocal space to any other reciprocal point in that space. Hence, the area or the smallest region which encloses inside that Bragg's plane gives the different Brillouin zones, like first Brillouin zone, second Brillouin zone, third Brillouin zone, and so on.